Hey there, POA students. Sorry for the delay on this video. I've not been feeling great, so I haven't put in as much time. But let's get it going. It's okay if you turn it in late. We don't take off any credit for late work. So let's get it going on homework 4.3. All right, so it says Sarah, the yearbook editor, and Mrs. Moore, the yearbook sponsor, are reviewing costs to produce the yearbook. New yearbook design software costs $800, and it costs $15 to print each yearbook. To find the variables in this situation. So I've got to think about the two kinds of quantities that I'm considering. And so I'm thinking that will probably have something to do with the number of yearbooks because it says print each yearbook. I think one variable better be number of yearbooks. And if you didn't see that directly, you might think to yourself, well, I know it's got to be the case that the cost of printing yearbooks must depend on the number you print. So I'm going to call that Y for number of yearbooks. All right, so new yearbook design costs $800. I see money in here as well. I'll highlight that in green for money. And so I think the other one better be cost in dollars. And let's just call that C. And I think if I really consider this, I'm going to look over here and take a hint from the input-output table here. It looks like the number of yearbooks produced is the input, and then the cost in dollars is the output. So I'm going to use that hint to know that the input variable is Y and the output variable is C. And the reason that that's the output variable is that the cost depends or is output by an input of yearbooks. So if I produce 0 yearbooks, my cost is going to be one thing. If I produce 100 yearbooks, my cost is going to be something else. Let's see what we can figure out about this situation then. All right, so number of yearbooks produced. Let's go ahead and put our variables in our table. Y was what we used for yearbooks, and C was our cost. So let's go back to the information. It costs $800 for the design software. And so if they buy the software but then they don't print any yearbooks, it'll still cost them $800. So I think across from 0, the cost should be $800. And then the cost is going to go up $15 plus 15 every time they print one more yearbook. So for these first two, when it's going up plus 1 yearbook over here, it's going to go up $15 over here. So 815 plus 15 is 830. All right, so I'm going to consider that for just a second before I move on to the next one. If across from 0 I have 800, I know my process must have plus 800 in it. So I'm going to go ahead and put that in every row down the way, and I'm going to use technology because I'm awesome. I don't know that this was actually faster, I was just experimenting with it. Okay, so we added 800. We know that's a part of every single row because 0 is across from 800. Now, to go from 1 to 815 and part of it being 800, I know that I'm just going to add 15. 800 plus 15 is 815. And from experience with these things, I know that I'm probably going to be multiplying. So I'm going to try multiplying by 1. And that's using the hint that Rachel pointed out in class that if the cost goes up $15, that's probably going to be part of your process. And I'm going to zoom in to make that a little bit neater. So plus 800, 15 times 1. All right, so I'm going to try that again down here, 15 times 2. Now 15 times 2 is 30. 30 plus 800 is 830, so it looks like it works. So I'm going to keep using that all the way down the table now. 15 times 10, 15 times 50, 15 times 100, and 15 times 500. All right, so I'm going to grab my calculator here. I'll do some of it with mental math. 15 times 10 is 150, plus 800 is 800, 950. Okay, 15 times 50 That's going to be 15 times, I think it's going to be 715.50. I'm going to double check myself with a calculator. 15 times 50 is 750 plus 800 is 1550. 15 times 100 is 1500 plus 800 is 2300. And double check myself again. And so I'm trying to model something right now that I hope you guys do, which is that try to do it in your head and then check yourself with a calculator. I'm totally right, so I'm good on these last two. 15 times 500. 15 times 5 is 75, plus 2 zeros is 7,500, plus 800 is 8,300, I think. 15 times 500 plus 800, 8,300. Cool. Super bodacious, awesome. That's right, I said bodacious. So that means that if we take our yearbooks and we multiply it by 15 and we add 100, it will give us the cost. I'm basically reading that right out of my rule here. And so if I take 15 times the input, that's our y. And I'll highlight that in, I think we were using red before. If I multiply 15 times the input, and I add all this stuff that's kind of floating around it. 15 is in there the entire time, and so it's going to be part of my rule. Plus 800 is in every single row, so that's part of my rule. And so 15y plus 800 equals the cost, C. And so I'll write that as my rule. 15y plus 800 equals C. Create a graph for this situation on the grid provided. Be sure to scale and label your axes. Okay, so I need to try to get all of that information in my graph. I need to have my horizontal axis go from 0 all the way up to 500. So let's go ahead and just do a guess and check method. So 0, and I'm going to say if I have to get up to 500, maybe this is 100, and this is 200. It doesn't look like it's going to fit, so 300. Nope, it's not going to fit, so I'm going to back up and try again. This is guess and check. I just tried something. So I'm going to make it a little bit smaller. I'm going to make every 4 bars 100. It's 200. Whoops, weird mark. 300, 400, and whoops, 500. Okay, and I'll draw my axis in. I need to make sure I label it. And so this is number of yearbooks. Let's check on my other axis. I need to get up to 8,300. So let's see if I count every 4 bars as 1,000. 2,000, 3,000, 4,000, 5,000. So clearly that didn't work, so I need to try again. Get my eraser out here. I'll maybe count by every 2 is 1,000. 3,000, 4,000, 5,000, 6,000, 7,000. We made it 8,000, 9,000. I'm going to put cost in dollars. I'll draw in my axis as carefully as I can. There we go. So now I need to try to plot these points, which I know I'm going to have to do a lot of estimating because it's rather difficult to plot these exact numbers on that graph. So my first plot is 0, 800, and so I'll plot in a different color. 0, 800 is somewhere around, I go 0, whoops, and then I go up to 800, so somewhere around there. All right, let's look at the second point. Come back up here. 1 comma 815. So 1 is super close to the axis. I think it's probably not even worth graphing. I'll come back to it here in a minute. I'm going to jump up to something that's much larger. I'm going to go to 50 and 1500. So I'm going to go to that one now. So 50 is right here. And I'm going to go all the way up to 1550, which is right about there. Okay. Let's keep going. 100 and 2300 is right about there. You might notice that they're forming a line. That's what I should expect. A nice linear pattern. 500 and 8300. So I'm going to go all the way out to 500 and go all the way up to 8300. So I can see this pattern extends in a pretty nice way. It looks like, I'll make my line a lot thinner than that. Let's see, it's going to be hard for me to make this straight. But that is pretty solid. Man, I'm amazing. Okay, and I'm going to go ahead and plot these last 2 points. They should fall right on the line right here. So I'll just put those in there. And so I've got every point in the curve graph. I'll have to put 10 in there as well. It's just, it should be bunched up on the line down there. So there, I've got a nice clear graph, labeled axes, a nice linear pattern that reflects a constant rate of change. Let's go ahead and look at the second page. Use your table, graph, and/or algebraic rule to help you answer the following questions. How much does it cost to produce 600 yearbooks? Explain how you found your solution. Okay, so I'm looking for 600 yearbooks. That's not in my table anywhere over here, so I don't think I'm going to use my table. It asks for a precise answer. If I look over here, I don't have 600 yearbooks on my graph. It would be out here, so I don't have that either. So I'm going to opt for the rule this time. Because I know if I know the input of y, I multiply it by 15, then add 800. And so that's what I'll do. I'm going to do 15, oops, I'll make my pen small again. $15 times 600 plus 800 is what I need to do. 800. Equals 15 times 6 is 90, so that means 15 times 600 is 9,000, plus 800 is 9,800. I'm going to double check my mental math. 15 times 600 plus 800, 9,800. Cool. So 9,800 bucks, or dollars, or whatever. How many yearbooks can be produced for $8,000? Explain how you found your solution. So I'm remembering something that we've done on some previous problems. Right now we're being given the cost in dollars, and we're supposed to work back to the yearbooks produced. So that means we can use our rule and work backwards. So I'm going to take 8,000 and I'm going to undo plus 800 by taking away 900. That's working backwards. So I get 7,200. Now I'm going to work backwards and undo times 15 by taking 7,200 divided by 15, which I'm going to have double. That's one I can't do in my head. So I'm going to divide that. I get 480 yearbooks. Cool. All right, so we used our rule to answer a couple of questions. Translate each of the following verbal descriptions into an algebraic expression. Use n for any number. Any number increased by 6. Increasing means adding, so I'm going to add 6. Any number multiplied by 3, that's n times negative 3. Any number multiplied by 2, then increased by 4. So then means that the multiplication happens first, so I'll do 2n to show multiplication by 2, and then increasing by 4. Any number divided by negative 4, then subtract 7 from the result. So again, dividing happens before the subtraction, so that's n divided by negative 4 minus 7. Any number decreased by 7, then divide the result by -4. So this means n minus 7, take the whole result and divide by -4. So the whole thing has to have a bar underneath it. Okay, translate each of the following verbal descriptions into an algebraic rule. The total cost of the order T is $11 multiplied by the number of pizzas ordered P equals the total cost. All I did was exactly what it said. $11 multiplied by the number of pizzas. 11 times P gives T. Cool. Number of songs that can be downloaded, S, is equal to, I'm just directly translating, equal to becomes an equal sign. S is equal to the number of credits in the account, C, plus an additional 2 bonus credits. S equals C plus 2. Cool. Direct translation, not that difficult. Decide whether two expressions are equivalent and explain your reasoning. X plus X plus X and 3X. Yep, those are equivalent, and that's because 3X just means 3 X's. And that's what X plus X plus X is. 2X plus 2Y and 2XY. No, you can't just add X's to Y's. And that's because you don't know what they are. You don't know how X and Y, what X and Y are, so you don't know if 2X plus 2Y really will become 2XY. Negative X plus 1 and negative X plus 1. I'm going to say no. I'm going to use an example. Negative 5 plus 1. Negative 5 plus 1 is negative 6. Now, if I use the same value for X, if they're equivalent, they should give the same thing. So negative 5 plus 1 equals negative 4. It gives a different thing. My counterexample. So for these, when you think that they are not equivalent, sorry about that, you can always just use an example. One example does not prove the case for yes, but one example can prove the case for no. So for 4x plus 5 and 4x plus 20, I'm going to say they are equivalent. If I remember correctly, 4x plus 5 is the same as 4 times x plus 4 times 5 by the distributive property. Which we learned about in class, distributive property, and that's just the same as 4x plus 20. So they must be the same because the property makes them the same. I believe that's all you had, so thanks for watching. I hope it was helpful, and again, I really apologize for it being a day late.